Okay, in the last few sections, we've discussed different types of linear equations, how we can represent different lines with certain characteristics, such as passing through a certain point, given a certain slope, finding the equation of the line, and then also being able to reproduce the graphs of the line given the equations, okay? And so now we want to move on to some special cases, comparing lines. Comparing two lines to determine whether or not they are parallel, perpendicular, or neither. Okay, so let's kind of talk about what those terms mean. Okay, because I mean something very specific when I say that. So let's say you have a line here, right? And let's say you have another line that runs on the side of it and they never intersect. Let's say they run perfectly side by side. Those are called parallel lines. Okay, they're parallel. They run parallel to each other. Okay, something that you might notice about them is that if they run side by side, they have the same steepness, right? They have the same slope. They have the same slope. Okay, so that's an important fact. Okay, so these are parallel lines. Parallel lines always have the same slope. Okay. Well, I promised perpendicular here as well, so let's talk about that. Let's say you have a line like this one here, and let's say you have another line, let's see if I can do this right, that runs something like that. Okay, they intersect each other, but they form a perfect 90-degree angle between them. Okay, perfect angle, perfect 90 degrees. Okay, and you see perpendicular lines all the time, right? When you look around the room, if you look at the wall, right, where one wall meets another wall, they usually form a 90-degree angle. That's because the two walls are perpendicular to each other. Okay, so perpendicular lines, perpendicular lines end up with similar slopes, sort of, right? They have opposite signs. The slopes have opposite signs. And you can see that just by looking at them, right? Notice the red one, right? It's slanted up, right? From left to right, it's slanted upwards. That would have a positive slope. The blue one is slanted down from left to right. So that one has a negative slope. So you're going to have a positive and a negative. That's what I mean by opposite signs. But you will also see that they are reciprocals of each other. Okay, in other words, they are each other flipped over. Okay, so for example, you might have a negative 2/3 as the slope of one of them. For the positive slope, you might have a positive 3/2. So the numbers are just flipped over. One's positive and one's negative. Okay, whereas if they were both parallel, they'd have the exact same slope. Okay, so parallel lines, perpendicular lines. And then what if it's not either one, right? What if it's something like this, where you have one line as usual, and then you have another line. They don't run side by side, and they definitely don't form a 90-degree angle, right? This is not a 90-degree angle here. They just kind of run into each other at some point. All right, these are just, they're neither parallel nor perpendicular. Okay, so nothing special here. They don't fit either of the two categories. All right, so that's the background information. Let's go on to our first example. Okay, in our first few examples, I want to determine whether the lines are parallel, perpendicular, or just neither one. Okay, that's what I want to determine. Okay, and Hawks will find a variety of ways to ask this question, so just be careful to read it. You know how to do everything that it says, just careful read. If it says first to put one equation in slope-intercept form, just do that first, okay? But, okay, anyway, so here is the instructions, abbreviated, and here are my two equations. So here's my first one. Okay, that's going to give me a line. And then here's my second one, which is going to give me another line, and I want to compare the slopes. So what I need to do is put them both in slope-intercept form so I can steal the slopes and then compare them. Okay, so let's move on. Let's simplify that first one. All right, so we got a lot going on here. First of all, I'm going to acknowledge the fact that this is a -1 sitting out in the front of these parentheses so that I can distribute that -1. So 7 minus 2y minus 3x equals, I'm going to distribute the 3. 3 times x is 3x. 3 times -y is -3y. Okay, so here we go. Looks a little bit nicer. Remember, to get it into slope-intercept form, I need to cancel out or get y by itself. I need to get y by itself. So I need y's on the left side. So what I'm going to do, and I'll write it out this time. I want to first get rid of this minus 3x. I do that by adding 3x to both sides. That'll take care of that. What else can I get rid of? Maybe this 7, right? I want to get rid of this positive 7 here. So I'm going to subtract 7 from both sides. Let me not put that minus 7 under this -3y. They're not like terms. I like to keep the like terms together. All right, so let's see. 7 minus 7 will cancel. I still have -2y. -3x plus 3x will cancel. 3x plus 3x is 6x. Minus 3y minus 7. Oh, I could have taken care of that minus 3y. Let me go ahead and take care of that now. I'm going to add 3y to both sides. That'll take care of that y on the right. Those cancel. -2y plus 3y is 1y. 6x, those canceled, minus 7. Okay, great. I put this one into slope-intercept form. Now I can identify the slope. I'll put a little 1 so I remember that's my first slope. That's the number attached to the x. That'd be 6. Okay, fun. Let's do the same thing for the right side, right? That y plus 2 equals 6 plus 6x. Remember, I want to get y by itself. It actually is mostly by itself. I just need to subtract this 2 from both sides. Oh, I have a constant here, so I can put it under there. There we go. Like terms. Those cancel. Y equals 6 minus 2 is 4 plus 6x. Now notice it's not in slope-intercept form. Technically that's okay. I'm going to rewrite it though. Put the 6x first and then plus 4. It's okay. They're all positive, so it doesn't matter the order. That's that commutative property there. Anyway, so the slope of the second one is 6. Okay, good. So the slopes are the same. Remember, same slope, parallel. Same slope, parallel. So these two lines are, in fact, parallel. Okay, let's do another one. All right, 4 minus 5y minus 6x over 2 equals 5x plus 5. Okay, that's my first equation. My second one, 8x minus 10y equals 8. All right, so here we go. That left one is ugly. All right, let's take care of it though. All right, I see a denominator of 2, right? I want to get rid of it. I'm allowed to get rid of it if I just multiply everything by 2. So that's actually what I'm going to do. I'm going to multiply this, all that by 2, and multiply this here also by 2. That's going to involve me distributing. Okay, 2 times 4 is 8. Minus 2 times all this stuff. Well, the 2's will cancel there. And I'm left with the numerator. Now be careful. Because those are on top of the fraction together, that 5y minus 6x, I should make sure that I indicate that they are actually together. Okay, that's going to make a difference with my signs, right? It's minus all that stuff over 2, right? So it's still minus all that stuff, so I'll put it in parentheses. All right, and then on the right, distribute the 2. 2 times 5x is 10x, and 2 times 5 is 10. While we're at it, we should go ahead and distribute that -1 here. Negative 1 times 5y is negative 5y. Negative 1 times negative 6x is a positive 6x. And then the right side still 10x plus 10. All right, now let's take care of some stuff. All right, y by itself. So I'm going to subtract 6x from the left side, which means I have to subtract it from the right side. Also going to subtract 8 from the left side. Got to subtract that from the right side. Okay, that'll take care of everything that's not y. All right, so 8 minus 8, that easily cancels out. 6x minus 6x cancels out. I'm left with negative 5y on the left. On the right side, 10x minus 6x is 4x. 10 minus 8 is a positive 2. All right, so we're mostly done rearranging this one. We need to divide everything by negative 5. So if I divide negative 5y by negative 5, I get y. 4x divided by negative 5 is negative 4/5 x. And then 2 over negative 5 is negative 2/5. So there is my first equation in slope-intercept form. So that first slope is negative 4/5. All right, let's see what I have left to do on the right side here. 8x minus 10y equals 8. I'll subtract 8x from both sides. Negative 10y is equal to negative 8x plus 8, right? 8's positive, so plus 8. Then let's go through and divide everything by negative 10. Negative 8 over negative 10 is 4/5 x, right? Negative divided by negative is positive, and 8 over 10 is 4/5. Positive divided by a negative is a negative, and 8 over 10 again is 4/5. Okay, so our second slope is the number attached to x, 4/5. Okay, let's compare them. The question again is, are these parallel, perpendicular, or neither? Okay, well, they're not parallel because here's a negative and here's a positive, right? Which means they're not the same. If they were exactly the same, it'd be parallel. They're not. Okay. Are they perpendicular? Well, we do have a negative and a positive, and we do need to have opposite signs in order for this to be perpendicular. But they're not reciprocals, right? They're not the same numbers of the fraction flipped over. So it's neither. They're not parallel because they're not the same. They're not perpendicular because they're not reciprocals, right? If this, let's say it were perpendicular, then instead of 4/5, I would need 5 over 4, right? That would have to be flipped over. And that's not what I have. So it's not perpendicular. It's just neither. Okay, let's do one more of those types of questions. Okay, 5x minus 4y over 2 equals x plus 2. There's my first one. And negative 6y minus 7x equals x plus 2. That's going to be my right side here. All right, and so the left side, I'll do it again, put it into slope-intercept form. Notice the fraction, it's over 2. How do I get rid of that? Yeah, I multiply both sides by 2. Okay, by multiplying the left side by 2, I don't have to distribute the 2 because it's just one giant ugly term, right? That 2 and that 2 will cancel out to leave me with 5x minus 4y. Okay, I don't have to put these in parentheses because there's nothing happening outside of those, right? The previous problem, there was like a minus sign or something, right? None of that's happening, so no parentheses necessary. 2 times x is 2x, 2 times 2 is 4. All right, so to get y by itself, I'm going to start off by subtracting 5x from both sides. Okay, if I subtract 5x from the left side, it cancels out that positive 5x. If I subtract 5x from the right side, 2x minus 5x is negative 3x plus 4. Finally, divide everything by -4. -4y divided by -4 is just y. -3x over -4 is a positive 3/4 x. And then 4 divided by -4 is a -1. Again, that constant doesn't really matter to me, right? All I care about is this 3/4. So my first slope is 3/4. Let's go on to the right side. So -6y minus 7x equals x plus 2. Okay, remember, I am trying to get y by itself, so I'm going to add 7x to both sides. If I add it to the left side, I have -6y, and the -7x cancels out. If I add 7x to the right side, that 7x adds to this 1x here to give me 8x plus 2. And then divide everything by -6. -6y divided by -6 is y. 8x divided by -6. Positive divided by negative is negative. 8 over 6 can be simplified. 8 over 6 simplifies to 4/3 x. And then positive 2 divided by -6. Positive divided by negative is a negative. 2 over 6 can be simplified to 1/3. All right, so I look at my second slope, -4/3. Okay, let's compare them. They are clearly not the same, right? So since they're not the same, they're not parallel. Okay, perpendicular. We have a positive here, and we have a negative. Okay, so it meets that. We have reciprocals, right? 3/4 flipped over. 3/4 flipped over is 4/3. Okay, so we have opposite signs, reciprocals of each other. We have perpendicular. In other words, if these two lines were graphed, they will actually intersect each other at a perfect 90-degree angle. All right, let's go on to a different type of question, okay? I want to do a couple of these really quick. So sometimes you'll be given one equation. You're given one equation. Let's see, 2y minus 7 equals -3, 2 minus 2x in parentheses. You're given an equation, and you're given a point. And so what is this representing? Okay, so this point does not belong to this line. Okay, that's the first thing. What I want to do is find an equation of a line that is parallel to the given equation. Okay, let me stop here for a second. So I'm trying to find another equation to where if I graphed this one and the new one, they'll be parallel to each other. Okay, that's what I'm looking for. Okay, but also I want that second equation to pass through the given point, that 5, -2. So find an equation of a line that is parallel to the given equation and that passes through the given point. Okay, so that's the instructions here. All right, so let's see what we can do with that. Well, the first thing I need to do is find the slope, right? If it's going to be parallel, then I know that my new equation will have the same slope, right? New equation, same slope. That's what that word parallel means. Okay, so let's rearrange. 2y minus 7 equals -3 times 2 minus 2x. Go ahead and rearrange that first. All right, so we got to distribute, right? Let's distribute the -3. Negative 3 times 2 is negative 6. Negative 3 times negative 2x is a positive 6x. Okay, let's get rid of that negative 7, that minus 7, the constant. We're going to add 7 to both sides. It cancels out on the left. Negative 6 plus 7 is 1. Okay, obviously I don't add the 7 to the 6x. They're not like terms. Okay, and then let's divide everything by 2. So divide by 2, divide by 2, divide by 2. All right, so it's written, it's not quite in slope-intercept form, right? That would be slope-intercept form. Same thing, but, you know, the slope of the first equation, the first line, is 3. So then I have to ask, what is the slope of the second line? Well, if I want it to be parallel, then they have to be the same. So I'm going to have to say it's 3. Okay. And then we also, remember, we're given the point. This new line has to pass through the point 5, negative 2. This should look familiar, right? I'm given a slope and a point, and I'm asked to find the line. Okay, we've done this plenty of times before. All right, so y equals mx plus b. Well, we're saying that m is 3. And now we have to find the constant b. To find the constant, we know that if you plug in 5 for x, you should get negative 2 for y. If you plug in 5 for x, you should get negative 2 for y. We still don't know what b is, but we can at least fill in all of that. And that gives us an equation that we can solve for b. 3 times 5 is 15. So negative 2 is equal to 15 plus b. And if I subtract 15 from both sides in order to get b by itself, I get negative 2 minus 15, which is negative 17. So b is negative 17. And so let's put it all together. Y equals 3x minus 17. These two equations are parallel, and the second one passes through that point 5, negative 2. All right. Let's do one more. Okay, so same question. Find the equation of the line that is, let's go perpendicular this time. That's perpendicular to the given equation and passes through the given point. Okay, so same question as before. This time the equation is 7x plus 6y equals 2y minus 2. And the point this time is 3, negative 3. Okay, so before I can move on, remember, I need to find the slope of the first line. Okay, the parallel and perpendicular terms, they indicate that we know something about the slope. So let's find the slope of the first equation. All right, so let's see. I got to do some stuff here, so I'll actually write it out. First, I need to get rid of the 7x. So I'm going to subtract 7x from both sides. Then I need to get rid of this positive 2y on the right side. So I'm going to subtract 2y from both sides. Those cancel. 6y minus 2y is 4y. Those cancel. Negative 2 minus 7x, they're not like terms, so I can't put them together. So I'll write them side by side. Here's my negative 7x. Here's my negative 2. Now I'll divide everything by 4. Divide that by 4. Divide that one by 4. Divide that one by 4. 2 over 4, of course, is 1/2. Okay, so I don't really care about, again, that 1/2. I don't care about what the constant term is, b. I know that the first slope, or the slope of the first line, is negative 7 over 4. Now I need to find the slope or the equation of the second line. Okay, well, if the first one's slope is -7/4 and I want a perpendicular line, okay, remember what the criteria are for that. You have to have opposite signs for the slope. The slope has to have opposite signs and be reciprocals. Okay, so the opposite of negative is positive. The reciprocal of 7/4 is 4/7. So positive 4/7. I don't need that plus sign. Positive 4/7. Okay, I have a slope. I have a point. I can use y equals mx plus b to find the equation. Let's plug it in. Y equals 4/7 x plus b. Okay, when x is 3, I don't know what b is, but y has to be -3, right? When x is 3, y is -3. Gives me an equation to solve. 4/7 times 3 is 12/7. Now I have to subtract 12/7 from both sides. All right, so that's going to be a little fun to do. If I subtract 12/7 from both sides, I'm just kind of writing it all at once, but here we go. Let's talk about how to figure this out. Again, feel free to type that in a calculator, by the way. It's a good idea to know how to do this quickly in your head, but anyway. All right, so I'm going to rewrite -3 as something over 7. Something over 7 because I want to be able to have a common denominator so I can carry out the subtraction. To figure out what goes on top, just multiply the whole number by the denominator that I want. 3 times 7 is 21. Do a quick mental check. 21 over 7 reduces down to 3. Okay, so we're all good there. So we have -21 over 7 minus 12 over 7. -21 minus 12 is -33 over 7. There we go. So let's put it all together now. We know what the slope has to be. Y equals 4/7 x, and b has to be -33 over 7. So -33 over 7. Okay, so that is the equation of the line that runs parallel to the given equation and passes through the given point. All right, and that wraps up the last section of Chapter 2, Parallel and Perpendicular Lines.